Hi everyone, I hope you all are doing well. So, today we will learn about languages of analytical chemistry. What is meant by analytical chemistry? So, analytical chemistry is a branch of chemistry that deals with the separation, identification, and determination of compounds in a sample. Example, we can take salt analysis, cations and anions determining the nature of sample present. So, analyte we are taking in a burette as it is a substance to be determined or detected or separated in same manner that is taken in the burette where analysis is started. It is a technique to identify quantity or quality of any sample components or substance by using manual method, chemical method or instrumental method. So, in this type of analysis, a strong acid is taken as titrant, whereas a weak base is taken as analyte. Always the strong acid or a base is always taken in a burette which is to be analyzed, whereas a weak is taken as an analyte in a beaker. Here we have four steps: determination, measurements, techniques, and last one is it is an act of measuring. So we will see one by one. Measurement first one is finding a number that shows the act of determining or amount of the state of being determined. Third one is second techniques. One is a technique is any chemical or physical principle that we can use to study an analyte. Next, coming to the last one, methods. Analytical chemistry method refers to techniques used for the detection, identification, characterizing, and quantification of chemical compounds. These were the four types in determining the titration taken in the analytical chemistry. Next, we will move on to the classification of analytical techniques. In this, there are mainly two types, that is, qualitative analysis and quantitative analysis. Qualitative analysis. Quality means the standard or the feature of one substance. Hence, qualitative analysis means qualitative analysis method deals with the determination of the quality of a particular compound irrespective of their quantity or concentration. In simpler words, the qualitative analysis does not measure the amount of a substance but measure the quality of that material. And one of the best example of this type of method is the observation of a chemical reaction, whether there will be a change in a color or not. Second point, the qualitative analysis method can be measured in different ways such as chemical tests, flame tests, etc. I have made a video on flame test. You can observe it in shorts. Several such tests are widely used in salt analysis, in bracket identification of cation and anion in inorganic salts. This was the detailed explanation about qualitative analysis. Now, further we will move on to the quantitative analysis. Second one is qualitative analysis. Qualitative analysis is a method of determining the absolute or relative quantity regarding the concentration of one or more substance present in a sample or compound. And here we can see the example. Take a sample of an unknown solid substance. The chemist first use qualitative methods to identify what type of compound is present in a sample. They adopt the quantitative analysis procedure to determine the exact amount or the quantity of a compound present in the sample. And some quantitative analysis techniques include gravimetric analysis and volumetric analysis. Here, gravimetric and volumetric are the two types of analysis performed in the lab for the determination of salts. So till now we have seen the types of analysis, that is qualitative analysis and quantitative analysis. Now we will move on to methods. Methods used in analytical chemistry. The first one comes is classical methods. There exist many classical methods of checking for the presence or absence of a particular compounds in a given analyte. One such example is a acid test for gold. Another example of classical method for qualitative analysis is the Castlemayer's test, which employs phenolphthalein as an indicator to check the presence of hemoglobin in the given analysis. Next comes flame test. As I have already said, I have made the flame test for different elements in my shots. You can just go and see my shots to understand the elements and their coloration when they are held to the flame, and observing the change in the color of the flame. Next is gravimetric analysis, is a classical method of quantitative analysis which can be used in analytical chemistry to determine the amount of water in a hydrate by heating it and calculating the weight of the water lost. And one of the better known classical analysis of quantitative analysis is volumetric analysis. In the titration method, a reactant is added to an analyte till an equivalent point is observed or obtained. Here the analyte is added till we get the stoichiometric point or a equivalent point, and the analytical process ends and it gives the equivalence point as a result and as an endpoint. Next method is instrumental method. In instrumental method we can see spectroscopy. Spectroscopy involves the measurement of the interaction between electromagnetic radiation and the atoms or molecules belonging to a sample. With the help of electrical and magnetic fields, the method of mass spectroscopy is used to measure the ratio of the mass of a molecule to its charge. A common instrumental methods used in the field of analytical chemistry is electrochemical analysis. In this method, the analyte is placed in an electrochemical cell and the voltage or the current flowing through it is measured. The interaction between the analyte and energy in the form of heat is studied in the discipline of analytical chemistry known as calorimetry. Calorimetry is mainly the instrument which is used for the measurement of heat of chemical reaction. And here is the last point. The calorimetry is an instrument, as I said, it is an instrument that is used to measure the heat of chemical reaction. So we have seen two methods, classical method and instrumental method. So the next is selection of an analytical method. In this there are mainly two types, accuracy and precision. First we will study what is accuracy, and next we will move on to what is precision and how it is analyzed. First one is accuracy. Accuracy is the ability of an instrument to measure the accurate value is known as accuracy. In other words, it is the closeness of the measured value to a standard or true value. It can also be said as concordance of true value. Accuracy is obtained by taking small readings. The small readings reduces the error of the calculation. The accuracy of a system is classified into three types as follows: point accuracy, accuracy as percentage of scale range, and the last one is accuracy of percentage of true value. Here I have mentioned how it is worked that is point accuracy, accuracy as percentage of scale range, and accuracy as percentage of true value. You can just read it out and analyze, and please take down somewhere, and it will be really useful for you. Here I have made the total notes and I have shown it on the screen, as you students can just write it somewhere and make your notes directly. There is no need of making again notes by yourself. Here is written notes. I want you people to write these points one by one, and you will understand the points. If you see this video again and again, you can't analyze it. Please take down these points somewhere and analyze them and study. Next, coming back to accuracy. In simple words, accuracy is, it is a degree of agreement between the measured value and the true value. An absolute value is seldom known. Seldom is nothing but seldom. It talks about itself. That is, it is talking about the measured value and its true value. Seldom is nothing but talking about self-dom. That is self, about itself. That is seldom known. And next point is, we can, by a analytical technique such as making comparison against a known standard sample or similar composition, arrive at a reasonable assumption about the accuracy of the method. Next, last point is, sometimes there is a difference generated between measured and true values, which can be represented as absolute error and relative error. Definition of absolute error. Absolute error is a difference between the true value and the measured value. For example, it is an analytical report says 2.62 grams of copper as 2.51 grams. Then the absolute error will be minus 0.11 grams. That is, we have to subtract 2.62 grams of copper minus 2.51 grams. Then the answer will be minus 0.11 grams. This is the answer. And if the measured value is the average of several measurements, the error is called as mean error. Next point is, the absolute or mean error expressed as a percentage of the true value is relative error. The above is given as mean error and the next one is relative error. We can see the definition here, and we can see the formula based on relative error is, relative error equals to measured value minus true value divided by true value into 100. Next, depending upon relative or percentage error, analytical methods are divided into three groups. First one is, if error is less than 1%, method is highly accurate. Next is, if method is between 1 to 5%, then the method is moderately accurate. Then the third point is, if error is greater than 5%, then the method is less accurate. The accuracy is measured in these terms. If it is less than 1%, then it is highly accurate. 1 to 5, then it is moderately accurate. If it is greater than 5, then it is less accurate. This was all about accuracy. Next is precision. It is a degree of agreement between replicate measurements of the same quantity, that is, it is a repeatability of a result. The precision may be expressed as a standard deviation, the coefficient of variation, or as a confident interval about the mean value. A good precision does not assure good accuracy. That is, accuracy and precision are completely different topics and different things. The volume of a pipette used to dilute each of a samples may be in error, which does not affect the precision, but it does affect the accuracy. In the other hand, the precision can be relatively poor and the accuracy may be good, though this is very rare. So, for the better understanding, I have shown the different figures of precision given. These concepts may be illustrated with targets. In first one, you can see all the dots are at the middle of the given circles, and at the second one, all are not at the middle, all are at the end of the given circle. Whereas in the last figure, you can observe that all the dots are in a different position and are at the different circles. Okay, now coming to the first figure, here you can see the good precision and good accuracy, because all are at the center, that shows good accuracy, and all are at a same position, all are nearby to each other, so they show the good precision. And coming to the second figure, here you can observe zero, or that is very poor accuracy. Here is very poor because all are at the end, but this shows the good precision because all the points are near to each other and at near to the same places. This shows the good precision. And coming to the last figure, here you can see the poor precision and poor accuracy because they are not at near to each other, which shows the poor precision, as though they are not at the center of the given circle, which shows they are not accurate to each other. I hope this clears the concept about accuracy and precision. This figure clears that what is accuracy and what is precision. I have written some of the points which you can read and take a good example and analyze by yourself. Even I have tried to clear the concept by using this figure. Next, the third one is sensitivity. It is a change in signal per unit change in the amount of analyte. It tells us how much the method is sensitive. Means if we change the concentration of analyte, how our technique respond to it. Taking an example, change in absorption in UV visible spectrometer by the change in concentration of the sample. It is often confused with limit of detection, which is the minimum amount of analyte that can be determined using a particular technique. This is sensitivity. And next one is selectivity. Selectivity, it is the extent that the method can measure the analyte of interest in the matrix of the sample being analyzed without interference from the matrix. The matrix is everything in the sample except the actual analyte of interest. Components in the matrix can interfere with determination of the analyte, that is, induced a matrix effect. Matrix effect may be either positive or negative. This was about the selectivity. We have seen the four topics, that is accuracy, precision, selectivity, and now we have seen the selectivity and sensitivity. Next is robustness. Robustness, it refers to the effect of deliberate change to the method of its performance. A method which has been developed to analyze an analyte whether it remain applicable when the matrix is changed. For example, if the same method remains valid for determination of Pb in water and soil, then it is called robust. A method that can be applied to an analyte in a wide variety of matrices is considered as robust. Robust means robustness. This other slide is also about robustness. For a method to be useful, it must provide reliable results. Unfortunately, methods are subject to a variety of chemical and physical interferences that contribute uncertainty to the analysis. If a method is relatively free from chemical interference, we can use it to analyze an analyte in a wide variety of sample matrix. Such methods are considered robust. And next, sixth point is rigidness. A method that is insensitive towards the change in experimental condition like temperature, pressure, humidity, catalyst, light, etc. is called rigid. Random variation in experimental condition introduces uncertainty. If a method's sensitivity K is too dependent on experimental conditions such as temperature, acidity or reaction time, then a slight change in any of these conditions may give a significantly different result. A rigid method is relatively insensitive to change in experimental condition. This is the sixth method of determination of analytical chemistry. And the seventh point is equipment. If equipment required for any particular method is too much costly, then it will be difficult to optimize this method. If equipment takes too much time to analyze a sample, this sometimes may be problematic if the sample deteriorate with the passage of the time. This was the seventh method. These were all the major factors, and the minor factor is also important, that is making of final choices. In this, unfortunately, the design criteria discussed in this selection are not mutually independent. Working with smaller samples or improving selectivity often comes at the expense of precision. Minimizing cost and analysis time may decrease accuracy. Selecting a method requires carefully balancing a design criteria. Usually, the most important design criteria is accuracy, and the best method in the one giving the most accurate result. When the need for result is urgent, as is often the case in clinical labs, analysis take time may become the critical factor. In some cases, it is the sample's properties that determine the best method. A sample with the complex matrix, and taking an example, may require a method with excellent selectivity to avoid the interferences. Sample in which the analyte is present at a trace or ultra trace concentration usually require a concentration method. If the quantity of sample is limited, then the method must not require a large amount of sample. Determining the concentration of lead in water requires a method that can detect lead at a parts per billion concentration level. Then the last point is selectivity is most important because other metal ions are present at significantly higher concentration. A method using graphite furnace atomic absorption spectroscopy is a common choice for determining lead in drinking water because it meets these specifications. The same method is also useful for determining lead in blood, where its ability to detect low concentration of lead using a few microliters of samples are important considerations. These are the choices which has to be made, whereas these are the minor things which are most important in determination of languages of analytical chemistry, and understanding each point during the analysis will be the most important thing in analytical chemistry. And even handling the instruments in the proper way also increases the rate of accuracy. Accuracy is to be maintained, and all the instruments in the laboratory has to be operated as they have to be operated in a good manner, also increases the rate of accuracy. I hope you all have understood the points I have explained in this video. I hope this video is helpful for you people. Thank you for watching this video.